In this video, I'll be explaining the selection sort and why it's in the order of n squared. So this HTML file is linked to an external JavaScript file, and it's only got a heading, and then this is what it looks like. We've also got the display of the search results showing how the array has been, or the output of the sort, which is a sorted array, 2, 3, 4, 5, 6. So let's have a look at the JavaScript file that does the work. So basically a function that takes in an unsorted array. So basically it takes in an argument as an array. Naturally, you would want to pass in an unsorted one for it to actually do the sort, which is this value here. So what's happening inside the function is we have an outer loop that's looping through the array from 0 to its length minus 1. So what that means is this array is composed of 5 elements. 5 minus 1 is 4. So the I is actually looping from 0, 1, 2, and 3. So it's going to go for 4 rounds and it will stop. Now, the reason why we don't want to loop through the last element is because by the time we've checked this value, it would swap. It would be sorted at the end. So there's no need to loop through the last element. Now, inside the loop, what we have is a variable called minimum index, which is pretty much the value of I. At the start of each round, we assume that the first unsorted element is the smallest element. So if I'm going to copy this one, so I'll use this Excel sheet as a visual to help us understand what's happening at the code. So in the first round, we assume 4 is the smallest value. Next, we loop through another loop. So this is pretty much j, represented by j. And j is running from I plus 1 to the length of the array, which is 5. So because it's less than, so it's going to go from I plus 1, so from 1 to 4, basically. And what that means is I'm going to just shade this in green to show you that this is the range of j. So j is looping from 1 all the way to the last element, which is index 4. So 0, 1, 2, 3, 4. So what's happening inside j is we are checking if this value is less than, if this value is smaller than the minimum index. So basically what's happening here is we are checking if there is anything smaller than 4 in this part of the array. And if there is, as soon as we find anything smaller, we update the minimum index with that new value. So here what's happening is we are going to check if 2 is less than the minimum index 4, and it is. So we do an update, and then we check the other elements. But because 2 is the smallest, the minimum index will actually be 2 once we finish from the second loop. And so what happens there is we will say, now do the swap the found minimum element with the first unsorted element. And so at that particular, or at this port here, change that value to the minimum index. So that would be 2. So whatever's sitting at minimum index. And then whatever's sitting at minimum index, which was 2, will now be equal to the first element, which is 4. So what that translates to is a swap between the two, just like so. So that's how the array looks like at the end of the round. Now what I'm going to do is I'm going to change that back to black, and I'm going to paste the element, or actually I'll write it 2, 4, 5, 6, and 3. So here's what the array looks like at the start of the second loop. The second round, which is when I is equal to 1. Now the minimum index is assumed to be 4. So that's going to be the minimum index. So now what we're going to do is we're going to search this part of the array. So I'm going to shade that in green. So j, this is pretty much j. And what we're going to do is we're going to be checking the smallest index. So here I'll just put a note. The smallest is 2. So what we do is we swap 4 with 2. And at this round, the smallest is 3. So we swap 4 with 3. So we find that the smallest element is 3. So by the time we finish from this part, we know that 3 is the smallest. So now we do a swap from 3 and 4. Let's bring that back to here. And now we will type in the values again. Now, when I is equal to 2, now the minimum index is 5. So we make that red. That's our minimum index. And this is j. So inside this loop, we are checking if there's anything smaller than 5. And indeed, we find that the smallest is 4. So the smallest is 4. And swap 5 with 4. So now let's type in these values again. 5, 6, 4. And let's bring this back to... Actually, we could just get rid of it, because at the start of the loop, now the minimum index is going to be equal to the third element, which is 0, 1, 2, 3. So that would be, the minimum index would be 4. I think swap 5 with 4. I forgot to do the swap. So that would be 5. And so this would be 4, 6, 5. Yep. And then we find that the smallest is 5. So swap 5 with 6. And so that's it. So that would be the range at that for J, is going from 4 to 4 basically. So this is how it works, and the output, so I forgot to do the swap again. So 5 and 6, keep forgetting this part. And at the end of the round, the array is sorted. So the output would be 2, 3, 4, 5, 6. What you can do is at the end of each round of J, we can console, but this is just for debugging purposes. If you're curious, you can display the array at the end of each round to see what that, it kind of is consistent to what we have. So in the first round, it was 2, 4, 5. So that was 2, 2, 4, 5, 6, 3. In the second round, it was 2, 3, 5, 6, 4. And then in the third round, it was 2, 3, 4, 6, 5. And in the last round, it was 2, 3, 4, 5, 6. It was sorted. And that's pretty much coming from the last call, which is this part here. So y is in the order of 2. So the time complexity is O(n), where n is the number of elements in the array. Now, O(n) means that the time required to run the algorithm increases quadratically as the input size increases. So the reason why it's n squared is because we've got that nested loop. We've got one loop inside the other. So the outer loop is going to run n times. The inner loop runs n minus 1 the first round, n minus 2, n minus 3, and so on, until we have one comparison in the end. However, the overall complexity is dominated by the total number of comparisons, and which is growing quadratically as the array size increases. Now, even in the best case, so in the best case, worst case, in the average case, it's n squared. Now, the reason why it's n squared in the best case is because the selection sort will still go through all the comparisons. It won't check if the elements are in the right order. It just will keep selecting the minimum in each iteration. That's why it's still in the n squared in the best case. So this makes the selection sort inefficient on larger lists, but it performs well on smaller arrays. I hope this video was helpful to explaining how selection sort works in JavaScript, and I'll see you in the next one.